Okay, this is just a quick explanation of how to solve systems of linear inequalities. This is for the people that were gone due to the musical and some of you who were absent. But I'm just going to show you real quick what this means. It's not a hard concept, you just have to understand what it's saying. Graphing linear inequalities in a coordinate plane, what they want to do here, so this is 9-5, so you need to pull this out real quick. What they're doing here is, first of all, having you graph this inequality. So remember, think of this as just like x plus y is equal to 4. Well, how are you going to graph that line? You can do it two ways. You can do intercepts, find the x and y intercepts, or put it in slope-intercept form. X and y intercepts are probably going to be the fastest here. So the x-intercept and the y-intercept. Now remember, in order to find the x-intercept, in order to be on the x-axis, the y value of the ordered pair has to be 0. So if y is 0, the x-intercept is 4. The y-intercept, in order to be on the y-axis, the y-intercept, the x value has to be 0. So if that's 0, y is 4. So the x-intercept is 4. The y-intercept is 4. Okay, now you're going to draw your line. Now remember, in inequalities, though, you've got to pay attention to right here. Is this going to be a solid or a dotted line? Hold on, I'm looking for my note card. So it's going to be a solid because the equal. So I'm going to take it, I'm going to graph my line. So that is graph, that line is this inequality. Now, remember, in inequalities, there's more than just one ordered pair. In an equation, only these ordered pairs on this line are solutions. But an inequality means there's many solutions, there's many ordered pairs. So in order to know which way you're going to shade, remember, you're going to test what point? 0, 0. So if you test the point 0, 0, 0, 0, 0 is less than or equal to 4, is that a true statement? Yes, that's a true statement. So you are going to include 0, 0 in your solution. So you're going to shade in everything, the same side that 0, 0 is a part of. Just going to shade that in. Now I'm going to recommend shade lightly. Shade lightly. So you're going to shade lightly. Or you could do a line, like you can graph doing kind of a lines here going one direction. Now we're going to look at another one. Now we're going to graph another equation. So the x-intercept, y-intercept. So the x-intercept here is going to be 2. The y-intercept, if you make x 0, what does y have to be in order to make that equal to 2? Well, it has to be a negative 2, because the opposite of negative 2 is 2. So the y-intercept is a negative 2. So the x-intercept is 2. Y-intercept is negative 2. Now you can graph that line. Pay attention. It is solid because of the equal sign. Okay, so now we're going to color in test 0, 0. So if you test 0, 0 in that point, 0 minus 0, is that greater than or equal to 2? No. 0, it's false statement, so 0, 0 is not a solution, so we're not going to shade above that line. We're going to shade now below. Notice, now you can either do the lines going the opposite way, or shade again. Shade at the same pressure as you did the other one. Typically what's going to happen now is that the solutions of both of these inequalities, the only common solutions that they have are the ones that are double shaded. So the common solutions are going to be right here. This is solution to one of them, this is solution to one of them. What about up here? There's no, that neither, if you pick an ordered pair and it's here, it shouldn't work in either oh my gosh, ordered, whatever it is, inequality. But all of these are solutions. What they're trying to do down here is get you to pick an ordered pair and to see if it satisfies. Well, pick an ordered pair that's in here in the darker area. I don't know, 3, negative 2. So 3, negative 2, does that satisfy both? Well, 3, y is a negative 2. Is 3, negative 2 less than or equal to 4? Yes, that's true. Does 3 minus a negative 2, is that greater or equal to 2? Well, that's 3 plus 2. And that's 5 is greater than or equal to 2. So that proves that those points are solutions to both inequalities. So when it's shaded darker like that, that means those are the solution to both inequalities. Okay? Okay. So now here it's kind of hard to tell on the color, on this copied paper versus the actual textbook that had different colors. But I believe it's going to be here that's going to be the common solutions. It's kind of hard to tell on your black and white copy. Some of you who have the colored copies actually are benefiting. But that's what it's saying, is that this is your common, these are your common solutions. Okay? I want you to try your turn 5, which you should have tried last night actually. But look down here on page 313. What do you think this represents? If they're not crossing at all, then they have no, the system has no solution. Individually they're solutions, but they don't overlap at all, so there's no common solution that would fit both of these. So that's what that means when it's graphed like that. Here, this is a little harder to tell with black and white, but notice these lines are parallel, they have the same slope, and what they're saying is when you shaded this one, it's going all the way up. This line here is just going up here. So the only common solutions are all of this here. And then you don't really call it anything. You can't call it all numbers or anything because not every number is a solution to both of them. So you would just show it by shading. Now here, this one's really tough to tell on black and white. But the thing is, here are the common parts. Like this one shaded down, this one here shaded up. So the colored copies, unfortunately, made it much nicer to see to where the common solutions are in the middle here. So again, same slope, different y-intercepts and stuff, but so that's kind of hard to tell. But what I'd like for you to do is try the Your Turn 8 and the, we're not going to do too much in this packet, 1, 2, and 3. One class had a really hard time. We didn't get a chance to talk about this. But we'll try to set that up on Friday too, but try it yourself. So number 8, 1, 2, and 3, and that's really it. I just wanted you to get practice and used to graphing it and seeing what the common solutions are. Okay, that is it.